Hello everyone, my name is Mr. Wu. Welcome to my channel. Today I want to talk to you about the 2023 VCAA VCE Maths Methods Exam 2 multiple choice questions and my responses to them. So first question is asking for the amplitude and period of a trigonometric function, specifically a sine function. So first thing you need to be aware of is if you look at the options, A is negative half and A is half. Right? So all you really need to do is to distinguish between the positive and negative. If you are familiar with trigonometry function, amplitude by definition, amplitude is a positive number. That's the definition of it, because amplitude is just the distance between the top y value and the middle y value of the trigonometry function. And it's an absolute distance, so it's not a signed quantity. And if you look at the function itself, there's a negative half in front of it, which is a dilation, so we know that A is a half. And then the period, well, period is given by this 2 pi over 3, because the 3 in front of the x is a dilation. It's a dilation from the y-axis, which means it affects the x values. So the original period is 2 pi of a basic sine x function, and so with the 3 here, 2 pi over 3 is the period. So E is the correct answer. And then question 2, we have a parabola ax squared plus 2bx plus c. A, B, C are all constant real numbers. The equation of the axis of symmetry. The answer is A, but if I write down the generic parabola, it's ax squared plus bx plus c. There's a axis of symmetry formula. Axis of symmetry formula, which is x equals to negative b over 2a. But all this means is b represents not really b. B represents the second. It just means the second coefficient. And let me put it this way. It just means the coefficient of the x term. And same with A. A just means the coefficient of the x squared term. A and B are just placeholders. B doesn't really mean B. B means the coefficient of x, and A doesn't really mean A. A means the coefficient of x squared. So don't get confused between the question ABC, the ABC in the question itself, and the ABC in the generic formula. So what we really need to do is to take negative and then stick in the coefficient of x. But in the question, the coefficient of x is 2b. So that's what I've written here, negative 2b, not negative b, because in the formula, b means coefficient. And the coefficient in the question is 2b. So negative 2b over 2a. Well, this is nice because the coefficient of x squared in the question is a. And we write that down, cancel the 2, common factor, and then the answer is A. Can be slightly tricky if you don't know what the formula really means. The letters themselves are just placeholders. You need to know the meaning of the letters. Okay, so question 3. Two functions P and Q, they are continuous over their domain, their respective domains, which are negative 2 to 3 and negative 1 to 5, the domain of the sum function, P plus Q. So the sum function is defined only when both P and Q are defined. Right? You need, for P plus Q to be defined, P must be defined and Q must be defined, which means the x values must be a intersection. So you're looking for you're looking for the intersection between the two domains, because you need your x value to be in both domains for p plus q to make sense. The best way to do this is to do a number line, to do a visualization. So -2 to 3 is this, solid dot -2, 3 open dot, and then -1, 5, open dot on -1, and solid dot on 5. And the intersection is E, so E is the answer. Okay, I have a system of simultaneous linear equation, and there's a parameter k. Kx plus 5y equals to k plus 5, 4x plus k plus 1 in brackets times y equals 0. The value, you need to find the values of k for which the system of equation has infinitely many solutions. I have corrected VCAA's wording. Infinite solution isn't really a rigorous phrasing in math. So math is a language, right? Math has its own terminologies, grammar, phrasing, and rules. It's a language in itself. So when they say infinite solution, I don't know if they mean the solution is x goes to infinity and y goes to infinity. Right? Infinity is not a number, but when they say infinite solution, I don't know if they mean the solution is infinity. X goes to infinity and y goes to infinity. So to have a rigorous wording or phrasing in maths, they need to say infinitely many solutions. So just be aware, if you are writing maths yourself, don't make the same mistake. Okay, get rid of that. And to do this is what I really did. So for two linear equations to have infinitely many solutions, let me actually write this down first. For two linear equations to have infinitely many solutions, you need the gradient of both. So let me actually say this. You need one line to be like this, and the other line to be the exact same line. Right? Infinitely many solutions. You want the two lines that look different in the equations to actually be the same line, which means you need the gradient to be the same, gradients same, and you need the y-intercept to be the same. You need everything in the equation to be the same, like in this format, mx plus c. So you need m is the gradient, you want that to be the same, and c is the y-intercept, you want that to be the same between the two equations. So, but those two equations are not given in the nice format, y equals to mx plus c, which means we can't tell the gradient easily, and we can't tell the y-intercept easily. So we need to turn these two equations into the nice format y equals to mx plus c, so that we can tell what the gradients are, make them the same, and we can tell what the y-intercepts are and make them the same. And that's what we are going to do. So it is a, well, this is my CAS calculator. It is a Texas Instrument Inspire CX algebra. I'm gonna go to solve. So k times x. Make sure you put a times in between k and x, otherwise it's not gonna work. Plus 5. What is it? 5y equals to k plus 5, and I'm making y the subject. I'm making y the subject now. It's still not exactly perfect, but you can now tell what the gradient is. The gradient is negative k over 5, basically. And if we expand the bracket, it's going to be positive k plus 5 over 5. That's the y-intercept. We've done that right? Yeah. So if you expand brackets and break it into the x term and the constant term, expand brackets, negative k plus 5, and then you have your x term, which is just negative k over 5, the coefficient of it, negative k over 5, so that's the gradient, and the rest is y-intercept, so k plus 5 over 5. That's why I have negative k over 5 over here, k plus 5 over 5 over here. Now the next one is 4x plus k, or k plus 1 times y equals 0. Again, make y the subject. So we can see here, there's no y-intercept, there's no constant term, there's only an x term. So the gradient is negative 4 over k plus 1. So I put it here, negative 4 over k plus 1. And the y-intercept is just 0 because it's just not there. So 0 over here. So I make the gradients, see, the negative k over 5 is the gradient. Make it the same as the other gradient. And then k plus 5 over 5 is the y-intercept. Make it equal to the other y-intercept, which is 0. So that's what I've written here. And you could use your calculator to solve these two equations now. And you should get k equals from negative 5. All right, question 5. Which one of the following has a horizontal tangent at 0, 0? Well, to be honest, the quickest way is to do a trial and error. Horizontal tangent at 0, 0, yeah. So this is what I will do. I'll go in here, manual calculus, and then go tangent line. I'm going to put the first option, x to the power of negative a third, and then put x equals to 0, and it's undefined, which means there is no tangent at the point 0, 0 for the first function, for the function in option A. So it's not correct. So there's no tangent there. So what about if I do the option B? So positive. And you can see the tangent here is x equals to 0. That's a vertical line. That's a vertical line. So that's not good within the horizontal line. Keep going. Keep testing. I've got a 2 over 3. That's undefined. So there's no tangent there. And then x to the power of 4 over 3. So I'm going to change that. Wait, that's still 3. 4 over 3. Here we go. 0. So y, that really means y equals to 0. So that is a horizontal tangent. But just to be safe, let's check the last option, and it's undefined again. So x to the power of 4 over 3 is correct, which is D. When it says 0, it really means y equals to 0, as opposed to x equals to 0. If it means x equals to 0, it's going to show you x. Otherwise, if it shows you a number, it's y equals 0. Just if you have time, this is if you have time, like from the calculator page, we pretty much know our answer. But just to be safe, you can graph it also. And you can see at the point 0, 0, the tangent is going to be a horizontal line, y equals to 0. I think you can even plot it. Yes, tangent right here. So you could even plot the tangent, and it will tell you that's the tangent, and it's y equals to 0. Just to show you how this works. I think you can move this. Nope, doesn't let me move it. Oh, never mind. Doesn't really let me move it. But you can even construct a tangent like this, and it will show you what it is. Okay. Question 6. We have an integral from 3 to 10. Some function f is equal to some number c, and then from 7 to 10, you integrating the same function f, and you get a different value d, and then it asks the integration from 7 to 3 f. Well, when I did this, I just did a number line. So from 3 to 10, the not the area under the graph, because it might be there might be some negative values areas. But basically, if I integrate from 3 to 10, the value is c, so I've put 3 and 10 here, and then above it I put c to encompass everything between 3 and 10. And in the same function between 7 and 10, I have d. And I know all the theorems of integration because I know that, and you're supposed to know this. So between 3 and 10 is really, I'm skipping a few notation here. It is between 3 and 7 plus 7 and 10, right? So that's one of the rules of integration. If your terminals are 3 and 10, then you can have a point in between the two terminals. For example, 7. So you go integrate from 3 to 7 plus integrate from 7 to 10. It will be a continuous 3 to 10. So once I have drawn this visualization, I can easily write down between 3 and 7, it's c minus d. Because the whole thing is c, part of it is d, so the part that I don't know is c minus d. But this is between 3 and 7, so to get from 7 to 3, it's just the opposite, it's the negative of my answer here, so d minus c. Next up, question 7. I have a natural log function, log e x. X is bigger than 0, and we have a square root function where x is less than 1. The domain of FOG. FOG means, the domain of the derivative of FOG. So slightly trickier. But FOG just means substituting g into f, so I get a log function, but then inside the log function I have a square root function. Okay, so the first thing I did was I drew the square root function. I took the negative out of the x because I need the coefficient of x to be 1 before I can see all the transformations. And so now I can see a reflection in the y-axis and a translation in the positive direction of x-axis. Okay, and then I ask myself, well, for this function over here, I need to sub all the y values into my log function. Is there a problem? Is there a problem when I sub all the y values into the log function? Yes, there is. There's one problem, which is this y value here. When the y value is 0, you can't sub 0 into a log function. But then everything else, it's a positive y value, so I can sub it in. And I also know this. I also know that this square root function is a 1-to-1, and the log function is also a 1-to-1 function. So all the positive y value going in here, all the positive values of the square root coming into the log function is going to yield a unique value again. And this curve is smooth, so when I sub it into log, it should also be smooth. There shouldn't be a break. There shouldn't be a break or a sharp corner, if you like. Sharp turn like this. There shouldn't be a sharp turn like this, like this even. Let me just do this. This is more of a function. There shouldn't be any behavior like this in a log function. So my derivative should be always defined. Because there's no break in the log function, and there's no sharp corners because the behavior of the square root is nice enough. And I get from negative infinity to 1, excluding 1. I can't include 1 because if I include 1, I'm substituting 0 into the log function, and that's not good. And you can always check this, right? You can always check this. So I'm going to come over here, and I'm going to put that in. Now it's giving me the tangent, so I don't want that. Okay, so you can see the function behaves very nicely. It's all smooth. There's no sharp corner. There's no break, and which means the derivative should be always defined until the asymptote here, which is x equals to 1. And even though the graph is very steep, the derivative is always defined. You can check this also if you want. You can compute the actual gradient when you're getting close to x equals to 1. It's very large. It's a very negative number, but it exists. It's defined. So C is the answer. Okay. A box contains n amount of green balls and m amount of red balls. A ball is selected at random. The color is noted, and then the ball is replaced in the box. In 8 selections, and we also have n not equal to m, what's the probability that a green ball is selected at least once? Well, at least once is a lot of possibilities. It includes once, twice, 3 times, 4 times, and so on, so that's annoying. So what we can do is we can look at the probability of green ball selected 0 times. We don't end up selecting a green ball. And because it is replaced, the ball is replaced, the probability of each trial, each time you pick a green ball, doesn't change. It stays constant. The probability of picking a green ball stays constant. It's a binomial. It is a binomial. And so you should have this formula, the binomial formula, somewhere in your notes. It's exam 2. Ideally, it's in your memory. Sorry, ideally, it's not in memory. Ideally, it's in your understanding. I always say you understand a formula and you write it down. You don't memorize formulas. So from 8 selections, we have 0. So selecting 0 from 8. and of course, there's 1. There's one way to select 0 things from 8 things. And then the chance of success, and then raise that to the power of number of success, which is 0, and the chance of failure, raise that to the power of the number of failure, which is 8. And chance of success is n over n plus m, and so on. Once you have that, you 1 minus that. 1 is 100% minus selecting no green ball, and you have the chance of selecting at least 1 green. Oh, by the way, selecting 0 from 8 is 1, and anything to the power of 0 is 1. So you have 1 times 1, and you're left with this thing here, and that's where option C comes from. Question 9. I have a hybrid function, tangent x over 2, and there's a domain. And then you have a sine function. There's a constant a unknown, and then there's a different domain. The value of a for which f is continuous and smooth. It just means your first part might go like this, and that's the point where it ends, the first part. But your second part isn't going like that, or like that. That's even worse. So continuous means the second part has to start where the first part ended, and it's smooth. So the gradient is the same. The gradient on this side and on this side near the point is the same. So you don't have something going like this. Okay, so I've written here continuous means a equals to n over 2. But then, well, this comes from the fact that all I have to do is find where the let me actually do this. So I need to find the end point of the first part. So tangent 2 pi over 2, so that's just pi. So, nope, I need to change my setting of my calculator, and that gives me 0. Right, so the end point is 2 pi 0, which means I need which means I need this to be sine a 2 pi. I need this to be also 0. Right? When x is 2 pi on the sine function, I need the y value to be 0 also for it to be continuous. So that's what I'm going to do. Solve this. I'm typing on a laptop, so it seems like my functions are coming out of nowhere, but trig function is just on this button here, the button next to equal sign. Okay, so I need this to be equal to 0 and a. And here we go. A is n over 2, a integer over 2. N1 is just calculator saying integer over 2. So that's what I've written here. But then I quickly realized all the options are in this format, except for B. B is definitely not true. But A, C, D, E are all okay in terms of the function, the hybrid function being continuous. And then I need it to be smooth, which means I need the gradient to be smooth also. So, sorry, gradient to be the same, which means let me minimize this. Okay, which means let me actually define this. Tangent x over 2. I'm defining df, stands for derivative of f, and we're gonna differentiate that just to check what it is. It's this, and it's correct. So I know the gradient of the first part at 2 pi is half. So the gradient at x equals to 2 pi is half, and that's what I need here. I need that to also exist there. And if you did it, so let me define this now. A times x, and then I'm gonna do derivative of g. That's just my naming of it. dg doesn't mean much except it's just arbitrary choice. Derivative of g is my naming of it. And then I am going to differentiate and just check what it is. That looks correct. And so I need the derivative of the second function when x equals to 2 pi to be half. And I'm solving for a. And as you can see, it doesn't really give me an answer. Right? I'm solving the derivative of the second part of the function, the sine function, when x equals to 2 pi. I need that to be half, but that's not giving me much. So that's not giving much. So what I need to do now is this. I'm going to define the derivative function again, but this time I take control of a. So the input to the derivative function is a n x. So now I can do some trial and error. So I do this. I try the first option. When a is -2, and when x is 2 pi, what do I get? Not half. So that's not good. Option B I've already eliminated from continuous, from the first criterion. So now I try -half as my a value. Wait. And I get half. Right, so when a is -half and x is 2 pi, the derivative of the second part is half. So I know C is the correct answer. But just to be safe, try the rest, if you have time, of course. That's -1/2, so that's not good. That's not what I want. I want the gradient to be half. And just to be safe, check the last one. When a is 2. Nope, not half. Okay, so continuous, I get some answer, and I can eliminate option B, but then the smoothness thing, I kind of had to do trial and error. There is a way to solve it properly if you did this by hand, but that would be a waste of time. Right? You can still find do this without trial and error. Do it the exact way using doing some calculation by hand, but let's avoid that. Okay, question 10. A continuous random variable x has the following density function, hybrid function again. The value of k such that probability of x less than k is 0.35. Okay, first thing I did was you basically have two parts, right? So from 1 to 6 to 9, and then you have some function like this. and you need a k value where if x is less than that, the area under the function is 0.35. The first thing you need to think is k here or is k here? That's going to make a huge difference, right? So that's the first thing you want to determine, which really means you want to find this area. Oh, wait. Yeah, that's what I want to draw. Which really means you want to find this area here. If it's bigger than 0.35, then you know k is here. If it's smaller than 0.35, then you know k is here. Because if the left area is smaller than 0.35, then to make 0.35, you need more area, so k is on the right. And that is what we are going to do. So the first thing to do, oh, by the way, I am a strong advocate for not defining hybrid function. Hybrid function, you can define hybrid function, of course, with the different rules and different domains. And you can do all your cast command with the hybrid function. Don't do that. Hybrid function, for some reason, is what I mean is this. Let me actually show you what I mean. Of course, you can do this, and then you're gonna come over here. That's where you can define hybrid function like this. Do your rule here, x minus 1, whatever, and do your domain here. And then you can do everything else from there. This, for some reason, is very computationally heavy for the cast. Right? What I mean is you can do solve, and you can do this. That's equal to something, and then x, right? If your function g is defined as a hybrid function with different rules and different domains, this command solve, and for that matter, any other command. So, I mean, any other command, you can find derivative as well. Any other command, it is very computationally heavy for the calculator. So the way the algorithms are written in the calculator makes it so. Right? There's a particular way that they wrote the algorithm to not deal with hybrid function well. So what's going to happen is it's either going to take a long time before it gives you the answer. It's either going to take a very long time before it gives you the answer, or it won't give you an answer. It will just get stuck, and you have to force exit the calculation, the thinking, or it's going to take a long time. So I almost never define hybrid function. The only time I define hybrid function is when I want to graph it. If I want to see the graph of it, I will define hybrid function and graph it, but that's about it. Otherwise, I never define hybrid function. And in this case, all I'm going to do is this. I'm going to treat them separately. And you should always do so. Treat each part of the hybrid function separately. So between 1 and 6, that's all I'm doing. X minus 1 over 20. X minus 1 over 20, X. And that is 0.6. So that's more than 0.35. That's more than 0.35, which means k must be here. Right? If k is here, if k is there, then the less than area is going to be way more than 0.35. Right? It's going to be way more than 0.625. So k must be here. K must be here. And that left area is 0.35. Which means I can do this now. So this from the very left end, which is 1, to some value k, and I should have defined this function in the beginning. X minus 1 over 20 dx. I want that to equal to 0.35, and I want to find k. And here we go. Root 14 plus 1. Not the negative number, the positive one. So B. Question 11. Question 11. Two functions f and g, they are continuous and differentiable, and there's some conditions given to you, x value, y value, x value, y value, and the derivative of them. The gradient of the function of the graph f times g at the point where x is -2 is, well, this is a product rule question. The gradient of a function that is two functions multiplying together. So to find dy dx, you need to do the product rule, which is this, f g dash plus g f dash, and then you sub x equals to -2 in there. And so -7 is this one, and then g dash -2, which is this one, so on, so forth. And you sub your values in, g -2 is this one, and then 3 comes from there, f dash -2. You sub everything in and you get 10. All right, question 12. The probability density function, I'm not sure why it's called mass function here, it's not wrong, but I think at least in the Cambridge textbook, it's called the probability density function. For the discrete random variable x is shown below, and it's got the outcomes, -1, 0, 1, 2, which is the x value, and the probability of each outcome, and they're all written in terms of k, so they're all unknown to us. The probabilities are not concrete numbers. And this is the annoying part. Well, if you try to find k, oh sorry, let me read the question. The maximum possible value for the mean of x. Okay. If you try to find exactly what k is, well, sorry, I should rephrase it. My first reaction was to try and find the exact value of k. What must k be? Well, if you add all the probabilities together, they must equal to 1. If you add all the probabilities together, it must equal to 1. So that way, I should be able to find what k is exactly. And that's what I did. And then turns out it's 0. If you look at it, x squared minus k squared minus k squared, they cancel out. 3k plus k is 4k, and then you do minus 4k, and they cancel out. And plus 1. So basically no matter what k is, k can be any value. If you add those 4 probabilities together, you will always get 1. So simply adding all the probabilities and making them equal to 1 doesn't solve for k, because doesn't matter what k is, k can be any real number. You add all those 4 things together, you will always get 1, because the k's cancel out. There's a plus 1 at the end. So that didn't work. And so all I'm going to do now is to just write down the mean in terms of k. So -1 times k squared, which is this. 0 times 3k goes away. 1 times k is k. 2 times the quadratic, and I get this. And I add them, and that's the mean. I simplify it to get this. And all I need to do now is to find the maximum of it. And you can, of course, graph this on your canvas. So let me come up here, and -3x squared minus 7x plus 2. And you should be able to get the maximum now. Is there any restriction on k before I do that? Yes, there is. The reason I say that, I'm thinking, well, that's the maximum. That's the maximum. But is this really my answer? Because k is negative here. K is a negative number. It gives me a maximum, but k is negative. So is that really my answer? Can k be negative? Well, turns out it cannot, because I have a bunch of restrictions here. K squared is between 0 and 1, which means k is between 0 and 1. 3k is between 0 and 1, which means from this, 3k being between 0 and 1, I get k between 0 and 1/3, so on and so on. And so from this, I should have turned √5 minus 2 into a decimal. √5 minus 2. Oh, by the way, I did this with my calculator. So I put 0 less than or equal to negative k squared minus 4k plus 1 less than or equal to 1 into calculator and solve for k. Because you just need this to be between 0 and 1. And I get this answer with 5 minus 2. 5 minus 2, 0.24, something like that, 0.24. So this is something like 0.24. Yeah. And then this is something like a 0.33. Yeah. So from this, I basically know that the intersection between all those is this. This one's the smallest one. K has to be between 0 and 0.24. So where is that? 0.24. I'm going to do a trace 0.24. It's here. It's almost at the x-intercept. And at this point, let me actually zoom in on this. Oh, wait. Let me zoom in on this so you can see that clearly. Right here. So if I do a trace now, yeah, right here. 0.24 is almost to the x-axis, x-intercept. So the maximum point actually happens basically between here and here. And so it's just the top line when k is 0. When k is 0, the mean is 2, and that's the maximum. That's the maximum. So basically, from 0.24, I have determined a domain for my mean function, k and mean. The horizontal is k, the vertical is mean. And once I have the domain, I look at it and I go, okay, it's not this end of the domain, it's the other end, because it's taller. So the mean is 2, the maximum mean is 2. And also I have to check this. I'm saying k is 0 here. Does that make sense? If k is 0, then this probability is 0, 0, 0, and 1. So that's fine. It makes theoretical sense. It just means negative 1 can never happen, 0 can never happen, 1 can never happen, and 2 always happens with the possibility of 1, which is fine, which is mathematically sound. So yeah, it makes sense. K equals to 0 makes sense, and it gives the maximum mean, which is 2. 13. There's an algorithm that applies Newton's method, and f is the function, df is the derivative, x0 is the initial estimate, and then they are doing this 3 times for I from 1 to 3. So I equals 1, I equals 2, I equals 3. So they're doing the iteration 3 times. Well, I shouldn't say iteration. They're doing the stuff inside the for loop 3 times. And all they're doing is they're applying the Newton's method formula, the initial x, the x value minus fx divided by df of x, which is the exact same thing as that in the formula sheet. This one here. That's all they're doing. They're just putting this formula into an algorithm. That's all that is. So if you are familiar with Newton's method, you don't need to be able to read pseudocode. Not really. Maybe some, but it tells you it even tells you 3 iterations. It even tells you 3 iterations. So you didn't really need to know how to read pseudocode or how to code. You just need to know what Newton's method is. And so you do Newton's method, which looks like this. The function is x cubed plus 3x minus 3, and that's the derivative. And 1 is the initial estimate, because that's what it says. The input is the initial estimate. The last input is the initial estimate. And it's asking for the return value, which means the final value, the final estimate at the end. It's just asking you what does Newton's method give you at the end when you do it 3 times, and those are the functions. Oh wow, let's just do it. define this to be x cubed plus 3x minus 3. And then we're going to define the, oh no, sorry, this one. We're going to define the derivative of f as well. I could just copy it from the question, but I'm lazy, so I'm just going to do this. You can check this. 3x squared plus 3 is 3x squared plus 3 on the question. And this is what I'm going to do. I'm going to define the Newton's method, which is just the formula. I'm defining Newton's methods, which is just the formula here. X minus fx over f dash x. And then the initial x, oh sorry, I need this. The initial x is 1. It's given in the question. 1. 1 is x0. x0 is the initial estimate. So all I have to do is put 1 in here. That's the first iteration. And then the second one. And then the third one. And I'm done. So all I need is this number, 0.81773. Sorry, it's 5 decimal places. 81773. And that's it. Question 14. Polynomial is this. The number of tangent to this curve that passes through the positive x-intercept is. Okay, so what I did first is to find the x-intercept using the calculator. So that's not too hard. And then I took the function and I found the tangent line at x equals to a. And then I looked for the amount of solutions where the tangent line goes through when x is 1/3, y is 0. And I count the number of solutions. It goes like this. So let me define my function. X times 3x minus 1, 3x minus 1 times x plus 3 times x plus 1. I'm looking for the x-intercept, so I'm making y equals to 0 and solve for it. And I'm looking for the positive x-intercept, so it's the last one, 1/3, 0, 1/3, 0. And I need the tangent to go through this point. Well, I'm not going to do this. 9 tangent line. So, and then I'm looking for tangent to the function f, but I'm looking for any tangent. I'm looking for not any specific tangent when x equals to a number. I'm looking for x equals to a, x equals to some unknown number, any number, and in this way I can find the tangent to the function at any point. Here's the equation, right, of the tangent. Something times x minus some constant, and the constant is in terms of a. So if I change the a value, I get a different tangent equation. But of course, it's best to define it. So my tangent function is defined. It's a straight line. It's something times x, right? So it's a power of 1. It's a straight line. And the constants are given in terms of a. And I need this tangent to go through 1/3 equals 0. The tangent has to go through x is 1/3, y is 0. And I need to find the values of a, in the tangent line that makes this happen. I need to find values of a that makes the tangent line go through 1/3, 0. That's all I'm doing here. And I have found 3 a values that allow this to happen. And so my solutions, the number of solutions is 3. So I just count, in the end, I just count the number of solutions for a. Okay. Question 15. Random variable, normal random variable. Mean is 100, standard deviation is 20. So that's x. And then you have a different normal random variable, which is y. Mean 80, standard deviation 10. Which of the diagram below best represent the probability density function plotted on the same set of axes? What I actually did, also it's a key. X is dotted line, so I've written it here, and the key says Y is solid line, so I've written it here. So what I actually did, I actually drew this myself without looking at the answers. So I'm just going to draw X like this. The mean is 100, so that's 100 over here. Let me draw X's. 100 over here, and standard deviation I don't really need to label it. But Y has a mean of 80, so Y has to be somewhere here. The top point of Y has to be somewhere on the left, and it's got a standard deviation of 10. So its standard deviation is the spread of data of the probability, which means it's narrower. The graph, the standard deviation is smaller. It's 10. So the graph, the points are less spread out. They're less spread out, which means the graph is narrower. The graph of Y is narrower than the graph of X. So it should look like this then. A very narrow and solid. I'm drawing this solid. Very narrow, and the top is 80. So, and then I compare my drawing to the rest. I basically get A. This has the wrong direction for Y. Same thing here, so that's gone. That's gone. So the top solid should be on the left of the top dotted line. This D has the same, the two graphs have the same standard deviation because they're the same extent of spreading out, so that's not good. This one is the opposite standard deviation comparison because the solid is more spread out. I need the solid to be more narrow, to be more close to each other, the points on the solid line, a solid curve. Okay, that's that. You need to understand what mean means and what standard deviation means. Okay, function f is e to the power of x minus 1. There's a product, the function f that we know, and the function g that we don't know. Multiply together gives you e to the power of x minus 1 squared. The rule of the function g is what? All I did was try and error. So I assume x to be 3, and I check it like this. So I define f to be the one I know, e to the power of x minus 1, e to the power of x minus 1. And then I'm going to define the hybrid as h. And I know that it's e to the power of something squared, x minus 1 squared. And so here's what I did. I did 3. H is 3, and I get 54.598. And then this is what I did. I did each option. So first option, e to the power of e minus 1. Sorry, e to the power of x minus 1. And if I do f3 times g3, I'm going to check what that is. Wait a minute. Why did I do something wrong here? Oh, it looks like A is the answer. How come I set B before? Hang on. Check. Is this G is this, and then F3 times G3 is this. Interesting. I may have written down the wrong answer in my first try of the question. So x minus 2, x minus 1. I'm now trying option B and try this again. That is still correct. Yep. If I do this now. Yep. If I do this again. Oh, okay. Ah, yes, that's what I did. When I checked x equals to 3, it didn't give me anything. Yes, 3 didn't work. When I tried 3, it didn't work. So then I tried 4, x equals to 4. So the right-hand side, when x equals to 4 should give me this number. And then I'm going to try the left-hand side. So let me go with the first option. This is option A. Go with the first option, and then yes, that's right. That's what I did. When I tried x equals to 3, it didn't work. So now I'm trying x equals to 4. So what the right-hand side when x equals to 4 is 8,103. And then I tried the left-hand side. By that, I mean I'm going to try g equals to the first option, so e to the power of x minus 1. And then I sub 4 in, f4, g4 with the option A, and the answer is wrong. The answer doesn't agree with the right-hand side. And then I try option B. Where is my option B? Here. And then I compute this again. This f4, g4 now agrees with the right-hand side of the equation here. So that's good. So B should be the answer. What about C? Yeah, let's try C. X plus 2, I think, times x minus 1. And then try that again. That does not, oh, something's wrong. Yeah, that does not agree with the right-hand side before. This one here, 8,103. So C is not the answer. Right, I'm trying C here. C is not the answer. And so on and so forth. So you can keep trying, and eventually everything is wrong except for B. This is the slight problem with trial and error. Sometimes when you try substituting a value, it doesn't really distinguish between the correct option and the wrong options, and that's okay. Once you realize that, you just change your x value or change the value you substitute, and you should be okay. You're more likely to find to pick a value to substitute that does distinguish between correct and incorrect options than not. Okay, now a cylinder of height h and radius r is formed with a thin rectangular sheet of metal. The metal is length x and width y, and here's a diagram, and you need to cut along the dotted line to make the cylinder. H is here, the circles are here, radius r, x is the whole sheet, and y is the whole sheet of metal. The volume in terms of x and y is given by something. Well, the volume is pi r squared times h. I think it's in the formula sheet also. Yeah, pi r squared times h. So here. And you don't have to memorize it, of course. Pi r squared is just the area of the circle. So you get the area of the cross section, which is the area of the base, and then you times the height. Okay, but it's in terms of r and h. We need the volume to be in terms of x and y. So we have written r and h with the volume formula, but we need x and y to appear in the volume formula. So let's do it. If you look closely, the circumference of the circle is y, and it has to be, otherwise it won't make the cylinder, right? It won't cut into the cylinder. Which really means if you take the circumference and you flatten it out, it should just be the length y over here. So we have 2 pi r equals to y. Right? That's the first thing. The circumference of the circle equals to y. And you can do some algebra and make r the subject. So r is equal to y over 2 pi. And then h and x. So the radius r also goes this way. It also goes horizontal because it's a circle. So it should be all the same. So the radius also go this way, r, and it also go this way, r. So as you can see, h, r, 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 r. So there's 4r here. There's an r here. There's an r here. There's an r here. There's an r here. H plus 4r should be equal to x also. All right. So where am I? Yeah. H plus 4r should be equal to x. X is the whole length of the rectangle. Which means I can write this down. H is equal to x minus 4r. But now that I have r is y over 2 pi. So I'm gonna substitute that, and I get 2y over pi. And then now I have I have r and h. So I can sub them back in, r and h, into the volume formula. So pi is pi, r squared is y over 2 pi, all squared. And then h is this thing here, all in brackets. And I can simplify, and eventually I will get b. Once you simplify the expression for volume, you should get b. Okay, question 18. There's a trigonometry function. There's a domain, negative a pi to a pi, and the function is sine ax. A we don't know, but it's positive. The number of local minima in the graph of y equals to fx is equal to what? Well, I think there's a way to do this properly, to prove this properly with algebra and arithmetic. But I chose not to do it, and I just did trial and error. So pick some value for a. I think that's what I did. Yeah, this is what I did. All right, here we go. Nope. Okay. I'm going to define f to be in terms of a and x. Right, a and x. And then it's going to be sine a times x. And then I'm going to go to my graph. And I'm going to go f, positive integer. So let me start with 2. So I'm saying a is 2. A is a positive integer. So I'm saying a is 2. And then the domain, negative a pi, 2 pi, negative 2 pi, and that is going to be less than or equal to x, less than or equal to 2 pi. Graph. There we go. Manual window fit. Yeah. And local minimum is 1, 2, 3, 4. So when a is 2, local minima is 4. When a is 2, local minima is 4. So obviously, that's not good. And sorry, the amount of local minima is 4, not local minima. The amount of local minima is 4. So that is gone. And that's gone. That's definitely not true. And then try again. So what if a is 3 now? If a is 3 now, so that becomes 3, that becomes 3. And I'm going to do another fit. So window fit. Okay, local minimum this time. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So when a is 3, amount of local minima is 9. So that's gone. That's definitely not true. 2 times A. 2 times 3 is 6. But it's not 6, it's 9. So that's gone. And so E is the answer. So 3, A squared, which is 3 squared, it's 9. So that's good. You can keep going. You can keep trying A equals to 4 and so on. And the answer should be E. Okay, question 19. Find all values of k such that this ugly function, x squared plus 4k plus 3 in bracket times x plus 4k squared minus 9 over 4 equals to 0, has two real solutions, one positive and one negative. Here's what I did. Define the function, as always, x squared plus 4k plus 3 times x plus 4k squared minus 9 over 4. That's correct. Yep, and then I'm solving fx equals to 0. And there are two answers, of course. One is this ugly thing, and the other is this ugly thing. And we need one to be positive and one to be negative. So there are basically two scenarios. What I mean here is really two scenarios. It goes like this. First scenario is if I make the first solution bigger than 0 and the second solution less than 0, or I can make the first solution smaller than 0 and the second solution bigger than 0, right? Because I have two solutions, right, in my calculator, on my calculator. So it's either positive negative or it's negative positive. So that's all I'm doing. So now I need to deal with them one by one. Deal with the two cases. First case, positive then negative. And I'm going to do this then. So solve, come up here. Right, here's what you do. On your calculator, you press shift. You press and hold shift. And you go to the right. And you've copied what you want. You have selected what you want. You press enter. And it comes down. And then you make it bigger than 0 and you solve for k. That's the answer. Write it down. At the same time, you want the second answer to be negative. So you come up, go to the right, and you hold shift, and you go to the left until you select what you want. You enter. You want this to be negative. You solve for k and you write that down. And so I've written it down here. And then you do the other case. You solve for the first answer being negative. You should get this answer in your case. And then you solve for the second solution being positive, and the k value is false. There's no k value that makes this second part positive. So it's false. So the second case is false. So and then you focus on the first case. Well, you need k to satisfy both. Right? K has to satisfy both conditions so that one solution is positive and the other solution is negative. Because that's what the question says. One positive, one negative. And you look at it close enough. Well, k bigger than negative 3 over 4. That's also in the first answer. K is bigger than negative 3 over 4, and it's also smaller than 3 over 4. So you take this, and that's your answer. Answer D. Option D. Okay, question 20. It's tedious. It's a very, very tedious question. So I'll just go through the thinking behind it. So f is a log function, x plus 1 over root 2 with the base e, and g is a sine function, but there's a very ugly domain, negative infinity to 5. It doesn't have a domain for log, so we will assume maximum domain, the implied domain. And then it wants both. It wants the largest interval of x, where both f of g and g of f exist. Okay, so here's what we do. We draw a table, domain range, fg. So we draw domain of f, domain of g, range of f, range of g. We write it down. So the implied domain for f is this. because you need the stuff inside the brackets to be bigger than 0. Otherwise, the log function doesn't work. There's nothing going on with the x. X can be anything. It's by itself. You just need x plus 1 over root 2 inside brackets. You just need that to be positive. So that's the domain. And the range is R. It's a log function. So it goes up and down to infinity. And if you really want, you can check this with your calculator. But really, you can also think of this as a transformation. The plus 1 over root 2 is a translation to the left. It doesn't affect the range. And then you have the domain of G, which is given to you, and you can graph this or whatever, or just visualize this in your head. And the range is -1 to 1 inclusive. And then it's a bit messy, my rough working out. But I did this first, FOG. So for FOG to exist, I need this. FOG means substituting G into F. So if I want to substitute G into F, I need the range of G to be a subset of the domain of F. Range of G needs to be a subset of domain of F. So I'm just going to copy that. So range G is this, domain F is this. And then I ask myself, is the first one a subset of the second one? And it's not, which means I need to restrict the first one. I need to restrict the range of G. So the only thing that's in trouble is -1, right? Because 1 is inside the this interval here. -1 is not. It's to the left of -1 over root 2. So I just need to do this. I need to change the -1 to -1 over root 2, and it's excluding. Then my range of G, like I need to make this interval, to be the range of G, so that the range of G is a subset of the domain of F. And you basically do it, use a calculator, right? So you find, the best way to do this is to graph G function, and then graph y equals to this line, this number, and y equals to 1. So you have two horizontal lines to mark your range on the graph with the sine function, and you look at the domain. And you look at the domain at the x value of G, that gives you the required range. And in this case, you might get you will get infinitely many, but you just pick one of them. I pick those. Yeah, and then you do GOF, which means you sub F into G, which means you need the range of F to be a subset of domain of G, and of course they are not. Range of F is actually R, all of real number, and domain of G is this. So you need to make the range of F -infinity to 5. Same deal, you graph the F function, and you graph y equals to 5, basically. And you look at your graph, and you determine the x values that give you the required range. And then you have your domain. And then, but this time you have two domains, basically. You're going to have two domains. Actually, before that, let me think about it a bit more. Yeah, you're going to have two domains. You need the intersection between them. You need the intersection between the two domains, because your x value needs to satisfy both condition for both FOG and GOF to exist. And so you go, okay, -0.79, that's outside -0.71. So -0.71 is what I want. And then 3.93 is to the left of 147. So I'm going to pick that. And -0.71 is -1 over root 2. So that's this one. And then 3.93 is 5 power 4. So that's this. So option A is the answer. And this brings me to the last point I want to add, which is a slightly tricky question, because when you first did FOG, when you first dealt with FOG, you know what you need to make the range of G. You need to make the range of G negative 1 over root 2 to 1. And if you graph this, you're going to have infinitely many options because the sine graph goes on forever. It goes at least to the negative side forever. And the sine graph goes on forever, up and down, up and down, up and down, up and down, up and down. So if you graph y equals to 1 and y equals to negative 1 over root 2, you should get infinitely many intervals of x that satisfy this. So if you pick the wrong one, you may not see your answer agreeing with any of the options. So when you pick one of the infinitely many possible answers for domain of G in FOG, you need to be slightly careful, look at the options and see which one on your graph, which interval on your graph would give one of the options in the question. Okay, that's all. Thank you for watching.